In this video, I'd like to talk about the graphs of exponential growth and decay. So in these problems, we're going to be given some exponential function and we'll need to make a picture of it. And before we look at any specific problems, let's think about what an exponential function looks like in its most general form. So let's say we have some function, g of x, and an exponential function can be written as a product of the starting term, or essentially the term when x is equal to 0, multiplied by the exponential expression term, or let's say b to the x power. And like I mentioned, a is just the starting value, or essentially it's the number when x is equal to 0. Since notice that if we plug in 0 to our function, we get a times b to the 0, but anything to the 0 power is 1, so it's just a times 1, which is a. And then b is what we call the base of the exponential function, and it could either be the growth rate or the decay rate, depending on the value of b. So if b is a number greater than 1, then we're going to have exponential growth. And if b is a fraction, then we'll have exponential decay. So looking at this function here, we have our starting value of 8, and we have our base here, which is 5/4. And since this is bigger than 1, we're going to be dealing with exponential growth. So it'll look something like this, where it's going upward. Whereas if we had decay, it would be coming downward like that as x gets bigger and bigger. So in graphing functions, one of the simplest approaches is to just make a table and look at specific x values and function values. So we have x and f of x here. So let's say when x is equal to 0, since that's going to give us our starting value. And if we plug that in, we get 8 times our base, 5/4, raised to the 0 power. But anything to the 0 power is just 1, so you get 8 times 1, which is 8. So we can start by graphing that. And let's see, we have 1, 2, 3, 4, 5, 6 tick marks, and we need to go to 8. So let's say they're by 2. So 2, actually, for the x values, we can go that, or we can use a scale of 1 for that. And for the y values, like I mentioned, we'll use a scale of 2. So 2, 4, 6, 8, 10, and so on. And so it goes through at 0, 8. Now let's plug in one more x value, though you can do a couple more if you want. And when we plug in 1, we get 8 times 5/4 to the first power. So this is just 8. Let me rewrite that. We have 8 times the fraction 5/4. And we can simplify 8 divided by 4 is 2. 2 times 5 is 10. So this will go through at 1, 10. And it's going to be a normal exponential function. We're not shifting it up or down. So it's going to have an asymptote when y is equal to 0. So the asymptote is always a key factor in these exponential functions. So let me just write that in to remind you of the word. It is bit of a complicated word, but this shows up in many different functions, but in particular these exponential functions. So essentially it's a boundary that the graph will not cross. And if we want, we can put in other points here, like let's say 2, though that's going to be off the graph. We'll have 8 multiplied by 5/4 to the second power, which if we just square that, 5/4 squared would be 25/16. So 8 divided by 16 is 2, so you get 25 halves, which would be 12.5. So we actually probably could fit that on. That's just going to be somewhere right about there. And we could also look at some negative values. So let's say we have -1. So when we have 5/4 to the -1, that's going to flip the fraction and become 4/5. So we had 8 times 4/5. Which would be 32/5, and 5 goes into that 6 whole times, and there's 2 left over, so that would be 6.4 as a decimal. And at this point, it's a little bit difficult to draw it exactly, but if you look at the Khan Academy exercise that this problem comes from, It uses an interactive grapher where you get to choose where the asymptote is, and you really just need to plot 2 points and then it will fill it in perfectly. So for us, we're drawing this by hand, and so it's not going to be perfect, but we can get a rough idea. So let me just fill in the curve using this y equals 0 as our asymptote. So again, notice that as the y values get more and more negative, the graph just gets closer and closer to this line y equals 0. And as the x values increase, the graph grows very quickly. Or in fact, going from one point to the next, as we increase x by 1, the y values are going to be multiplying by the base. Every step of the way, they multiply by 5/4 or 1.25.